Hi everyone, Doa Chapter again. Welcome to the Introduction to Arduino and MSP lecture. This is a lecture for folks who are not familiar with microcontroller coding, specifically Arduino and its software Arduino IDE. It can also be helpful for those of you who want to learn how to connect Arduinos to MSP, which is the programming software we're using for this workshop. Again, this is an introductory level video and it's aimed to help you get started with connecting your Arduino data to the MSP. In the second pre-workshop video, we covered how to send your sensor data to Arduino server. In this lecture, I will show you how to send this data to the MSP software. In this lecture, I will first talk about the Arduino board and its components. I will walk you through the code on the Arduino IDE side and later show you how to receive this data on the MSP side. Lastly, I will briefly overview different types of data to sound mappings. Here's our controller board, Iligo. This is an equivalent to the Arduino Uno boards and a very similar pinout. Here on the top, we have the USB port that is used mainly for powering up the board and uploading sketches to the board, telling the board what to do. And it will also allow us to communicate with our computer and our Arduino using serial communication protocols. If you're not using the USB to power your board, there is also a power port on the bottom left corner. This is useful if you want to make your instrument portable and now want to connect it to the computer all the time. On the bottom and top edges of the Arduino, we have the pin ports. These pins allow us to connect sensors and electronic components to the controller. Along the bottom row, we have the analog pin, and on the top row, we have the digital pins. Analog pins read sensor data from analog sensors. Most sensors you might be using, I suspect, will be analog. The digital pins only read ones and zeros. Sensors like push buttons are digital sensors, but you can also connect your analog sensors and read only low and high data as a digital input. We also have the power section of the board in the middle bottom section. These pins include pins to supply power with 3 or 5 volts. There is also ground pins. So this is the hardware side of the board. The other side is the software side, the Arduino IDE, where we'll be using the software to tell the controller what to do. The software we use is the software called Arduino IDE, Integrated Development Environment. Just to remind you again, you want to download the software from the Arduino.cc/en as in English /software by choosing your machine's operating system. Let's get started with our first Arduino project. We will start with a sketch. These are the programs we write and save our codes as .ini files. When you open a sketch, you see two voids. One of them is the setup and the other one is the loop. Like the name suggests, in the void setup, we set up the code. Anything in this function is going to run once when we run the code. It is used to initialize and set up the board. However, in the loop function, we will write the main code that will keep looping continuously. Before moving forward, recall the first video of the pre-workshop mini lectures. You want to set the board and port of the board properly. If you haven't done this so far, please revisit the video titled Lecture 0.1 Getting Started with the Arduino Kits and get your board set up on the IDE. If you remember our first sketch in our earlier video, I will use the same circuit to receive the LDR data. LDR circuit consists of a light resistive sensor and a 10 kilo-ohm pull-down resistor. The circuit is powered by either 5 or 3.3 volts pins. We connect the pull-down resistor between the LDR sensor's other pin and the ground. The sensor data is taken from the same pin where the resistor connects, and it's connected to the Arduino's analog pin. Any of the analog pins from A0 to A5 should work, but make sure that the pin that you select is the same pin that you code in the Arduino IDE sketch. On the IDE side, we will start with an empty sketch. The first thing I will do is to tell where we will plug the LDR into the Arduino board in the code. I start by defining which pin is connected. Later, I define the baud rate of the serial communication. If you remember from the earlier video, the baud rate needs to match in the code as in the serial monitor's baud rate to properly monitor the data you're reading into. After this, I will use the command analog read to read the analog data from the sensor, and I assign it to a new integer value. I named it the sensor data. Next, I send the sensor data using serial communication. Serial communication is one of the protocols we're using and sending and receiving data using the USB ports. Serial monitor can be accessed from the top right corner. I also add a small delay to be able to observe the data in the monitor. Please revise the pre-workshop videos for how to monitor serial data using Arduino serial monitor. Alright, now we're going to switch to sending this data from Arduino IDE to Max MSP. Max MSP is a graphical programming language, meaning instead of writing a script-based code, we program here using objects and connecting these objects to each other to program our interactive systems. They are used for many applications like sound synthesis, audio programming, composition, visual effects and performance, and other interactive system programming. We will focus on the audio programming side for now. Now, create a new Max patch. These are like sketches in Arduino. The programs are called patch in Max. You can monitor the messages from the Max console, like error messages or data or messages that you want to display on this console side. Max uses an object called serial in order to send and receive serial data. And to set it up, we need to define the port that we are using to send this data from the Arduino controller. This one is a USB port. To figure out what port we're using, I will create a print object and connect the top pin of the serial object to the print object. When I click print, the console window should tell what ports we have on our computers. The USB modem one will be the Arduino port. So I will indicate the code of the port and say serial J. Depending on what kind of serial ports that you have on your laptop or your computers. For example, I have several Bluetooth objects, so I see them before the USB port. You might have a different number or different code for your Arduino boards. Finally, we need to indicate the baud rate that we're using. And remember, this baud rate needs to match the baud rate in your Arduino code. Now I add a toggle object to start displaying the data and a metro object. To organize the data, I first generate a select object to look for a new line character. I group them together, convert integers to symbols, and convert symbols to messages. Lastly, I create a number object to display the sensor data. This is where we should see the sensor data we're reading from the Arduino board, sending it to the Arduino IDE, from Arduino IDE, reading again from the serial communication on our MSP side. One thing that is interesting to note here is that you can, on the very bottom corner, you can lock and unlock your patches. So if you lock it, you'll be able to interact with the toggles. And if you unlock it, you'll be able to control and modify your code. Now I'm using the circuit to change the light intensity by changing my hand's proximity to the sensor. And the data is going up and down. This data is the same data that I was monitoring on the IDE side, if you remember the pre-workshop lectures. I hope this was helpful for you to send your sensor data from Arduino to MSP. For other sensors, if you need any help with any stage from constructing the circuit to Arduino coding or to MSP, feel free to reach out to me or Lloyd. Because we'll be dealing with a lot of mapping between the data and the sound parameters and the musical ideas that we're using, um, I will I will talk about it very briefly, a few sound mapping strategies. Basic four mapping strategies are one-to-one, one-to-many, many-to-one, and many-to-many mappings. Lately, learning-based mapping strategies have been frequently used. These learning-based mappings are useful strategies when the data is complex and difficult to interpret, such as muscle contraction data as in EMG sensors. If you have a simpler system, these four strategies might help you be more expressive and give you more control over the composition. So the first one-to-one, means that one synthesis parameter is driven by one sensor data. It's a direct mapping. While in one-to-many, you may have one sensor data controlling multiple sound parameters. The opposite of this would be when one sound parameter is controlled by many sensor data. This mapping is called many-to-one. And finally, in many-to-many, you have a more complex system when you observe a combination of all mapping strategies, from one-to-one to many-to-one or one-to-many. They will be used in combination. There may also be more complex system with multiple layers of parameter mapping. This is a very short overview to familiarize you with the existing mapping strategies. I personally prefer using more complex mapping systems like many-to-many, but depending on your designs, you might choose a simpler one or learning-based one. For an exercise, I want you to think about your sound design and what kind of musical composition you need. Which sound synthesis parameters does this composition require? And create a diagram, any kind of diagram, of your mapping between the sensor data you're planning to use and the sound parameters your music requires. As always, feel free to ask any of the questions that you have, either via email or in the office hours. After this lecture, we will be mostly working on your individual projects. So now it's time to get started with prototyping and start thinking about your design specifications. Good luck!